In this video, we'll focus on writing linear equations in two variables. So one useful method for writing an equation in two variables is what we call point-slope form. The slope-intercept form that we have seen when we're graphing is great, but we have to know the y-intercept and we have to know the slope in order to use that. Sometimes we do know the slope, or we have enough information to find the slope, but we don't necessarily have the y-intercept. Point-slope form allows us to use any point on the line and the slope to write an equation of a line. So I want you to imagine 2 points that are on a line. So here I just have an arbitrary line being drawn. So we have 2 points located on this line. Remember, a line is just defined by 2 points. As soon as you have 2 points, you have a line. If you have 1 point and you know the slope of the line, you could also get that line as well. So we're going to imagine these 2 arbitrary points that are located here. We're going to let 1 point be fixed and let the other point vary. So let's imagine that we fix the point that's labeled x1, y1, so that stays put, but we take this point x2, y2, and we allow it to just move around, so it can vary anywhere along the line. So instead of calling it x2, y2, we're going to call it xy. So if you recall, the slope formula that we had talked about subtracts the y values and makes a ratio over the difference of the x values, right? So the slope formula in general was y2 minus y1 over x2 minus x1. But now, since we are allowing that second point xy to vary, right, to move along the line, we are replacing the y2 and the x2 in that slope formula with just plain old y and x, right? And that's going to be the point that can live anywhere. So if we were to take this slope formula and just rearrange it so that we've solved for y minus y1, we would get the version that you see down below. You could think about that as cross multiplying as well. So if you think about m as m over 1 as a fraction, we would multiply m times the denominator here, multiply y minus y1 times the denominator m, which would be 1, and that would also lead you to this version of the equation. The same relationship is held between all the variables. We would just have rearranged that equation. This is our point-slope form. So here's just a summary of the equations of lines that we've seen so far. So we had the standard form of a line. That was our definition of a linear equation in two variables. Ax plus by is c. So a and b are the coefficients, c is another real number, x and y are the variables. Slope-intercept form was very helpful when we're graphing. Y equals mx plus b. In that case, the m is the slope, the b is the y-intercept. Now we have this point-slope form, y minus y1 equals m times x minus x1. Here m represents the slope, and x1, y1 is any point on the line, any point. Then just to return back to our horizontal and vertical lines are in the form y equals b. B is the y-intercept, just some real number. Vertical lines in the form x equals a, and a is the x-intercept, which is just some real number as well. So when we're writing equations of lines, we're going to first begin with the point-slope form if the slope is defined. Because for that point-slope form, we need the slope and we need any point. Once we have that point-slope form, we're just going to rearrange it to write the equation in slope-intercept form, that y equals mx plus b form. Let's use that for the examples that you see on the slide here. All right, so for the first one, we're going to write an equation of a line with slope of -2 containing the point 1, -5. So I have the important information here. So we're told that the slope, m, should be -2, and the point that is one of the points on the line is 1, -5. So I'm just going to write out my point-slope formula. Y minus y1 equals m times x minus x1. So the the x1 and y1 are the points. I like to label my point, x1, y1, just so I remember where everything goes in the formula. So I'm going to substitute in what I have. The y and the x just stay y and x, right? Because we're writing an equation, so our equation is still going to have y and x in it. Y minus y1, which is -5. You might have double negatives when you use this formula, just like in your slope formula, so be careful. So I have a minus in the formula, and then here the y-intercept happens to, the y-coordinate happens to also be negative, so I have two negatives there. Equals m, which is -2, times x minus x1, which is 1. So once you substitute in, it's just a matter of solving for y, which usually takes 2 steps. Distribute the slope, and then add or subtract to get y by itself. In this case, I have a tiny little extra step. I'll just take care of that double negative. So y plus 5 equals, and I'll also distribute in this step, -2x plus 2. And now, just to isolate y, so I get my equation y equals mx plus b form, I'll subtract 5 from both sides. Y equals -2x minus 3. So this form of the equation is nice if we were going to go ahead and graph. We then have the y-intercept at -3 and we have the slope at -2. Do notice that the slope hasn't changed, right? The slope that we wanted our line to have is -2. This point does live on this line, so if we were to graph that line, it should pass right through that point. Going to our second example, write an equation of a line with slope of 1/4 containing the point -8, 6. So I have that here as well, slope of 1/4, point -8, 6. So again, as long as you have the slope and a point, you could always go to that point slope form. Y minus y1 equals m times x minus x1. I have my slope, my point, x1, y1. Alright, substituting in, I have y minus 6 equals 1/4 times x minus -8. Again, you might have some double negatives. Here I have a double negative inside the parentheses. Alright, you know what? I'm just going to take care of that double negative, make them both positive instead of rewriting there, because I want to distribute as well. Y minus 6 equals 1/4 times x is 1/4 x. 1/4 times 8 is 2. And if you're uncertain about that step, 1/4 times 8, or 8 over 1. 1 times 8 is 8. 4 times 1 is 4. And then when you simplify 8 over 4, you have 2. And then finally, I just want to get my y alone, so I'll add 6 to both sides. And we have y equals 1/4 x plus 8. So again, my slope is still the same, 1/4, so always check just to make sure that that holds true. And this is my y-intercept, so if I were graphing, I could use that to graph. Alright, and the last example we'll look at for this video, we have write an equation of a line containing the points -1, 3, and 2, -4. So here we're given 2 points. If we want to use the point slope form, we need the slope. We don't have the slope directly, but we can find the slope because we have 2 points. So the first thing we'll have to do is find that slope using the slope formula. So writing out my slope formula, y2 minus y1 over x2 minus x1. I like to label my points when I use the slope formula. So I just always call the first one x1, y1, and the second one x2, y2. It doesn't matter which one you pick. And I'll substitute those values in. So m equals y2, it's -4 minus 3 over 2 minus x1 is negative, so double negative down below. So I'll take care of that double negative at the bottom. 2 minus -1 becomes 2 plus 1. And then on top, -4 minus 3, So 2 negatives. I'm adding, so it stays negative, so it's -7. On the bottom, I have 3. So my slope is -7/3. All right, so I'm going to use that point and use that slope and one of my points. It doesn't matter which one I use. My point slope form. Let me write out my point slope form. Y minus y1 equals m times x minus x1. Now my slope has a denominator of 3. So the only thing I might have to worry about, because that slope is going to multiply in here, if I had a coordinate, a point with an x coordinate that was divisible by 3, it might be beneficial for me to choose that one just to make my work with fractions a little bit easier. But here are my x coordinates, neither of them are divisible by 3, so I have to deal with it anyway. So I'm just going to stick with my x1, y1 that I've labeled, and I'll use that same x1, y1 here. It doesn't matter which point you pick to go here. So y minus, I'm going to stick with this one, 3 equals my slope, -7/3, times x minus -1. So I have double negative there. All right, so we take care of that double negative first. 2 negatives make positive. And I'll distribute that -7/3. Y minus 3 equals -7/3 x. Luckily, this is just a 1, so -7/3 times 1 is -7/3. Now I do need to add 3 to both sides. All right, so I have to work with some fractions here. It's not a big deal. Let me just get this set up. So I'll have -7/3 x, and then whatever that sum is. Let's do that off to the side here. All right, so I have -7/3, it's a 7, plus 3 over 1. All right, so that 3 over 1, I can make the same denominator as the 7/3, so I'll just multiply top and bottom by 3. So that gives me -7 over 3 plus 9 over 3. -7 plus 9 is 2, so that is 2/3. Not so bad. Plus 2/3 here. So my equation is now in y equals mx plus b form. It's not nice to graph by hand at all because it has a funky y-intercept at a fractional point. So this would probably be something that I would maybe choose a different method of graphing or use some sort of graphing utility. But luckily we don't have to graph. We were just asked to write the equation. In the next video we'll focus on parallel and perpendicular lines.